Well, hello there. This is KP the Math G on a really nice, beautiful Sunday in February. And for today, we're going to do part D of the 2005 free response question number 5. It has to do with a car traveling in a straight line, and this is the velocity graph that this car makes. Okay, this velocity is measured in meters per second. Time here, of course, is in seconds, and we have a few points here: 4, 20, 16, 20, and of course 24, 0. So we're looking at this graph here. We have to look at that. Now, let me explain something to you about this right here. Excuse me, let me shut the door a little bit. Okay. It says here, this is part D, find the average rate of change on the interval from t between 8 and 20. And then the second question we need to answer: does the mean value theorem apply to this interval? And it may be a question of why or why not. In one of our previous problems, we had to deal with this v prime at 4. That means the slope of the tangent line here at t equals 4. We found on this side to the left of 4 that the slope was 5. We found to the right, approaching, that the slope is 0, and therefore, because these slopes are different, that means then that this is not differentiable at t equals 4. We don't know the slope. This is, you can't determine what this is here. Okay, at t equals 4. All right, so this is not differentiable at t equals 4. Okay, simply because we have two different slopes. Okay, and so the limit does not exist at t equals 4, and so we see that this is not differentiable here. Look over here. Do you see another corner point that's not differentiable? Yeah, right here. This point here, x is 16. Now look at this very carefully. T is between 8 and 20. So what we're looking at, 8 has a slope and 20 has a different slope. Okay, so kind of keep that in mind, although we still can find the average rate of change. So let's see, what is the average rate of change? Well, we can look at it in two ways. One way is to say the average rate of change is v at 20 minus, and this is what we might say the slope of the secant line, right? V at 20 minus v at 8 all over 20 minus 8. Another way this can be written, and this is the right way to look at it, this is one way. Another way that can be done is you can just say, well, I'm going from 8 to 20. Alright, average, you put this fraction on the outside, and you simply do 20 minus 8 right here. 20 minus 8 right out here. And then what you do is v prime at t, that's what we're dealing with, is the slope of the tangent line to the curve. Alright. right, dt, all right. Now that simply means this is actually 1 over 12, which, by the way, what's this equal to? 20 minus 8. That's correct. It's 12, isn't it? Okay. Now, right here, let me make this where it's not so stretched out. Okay, now 20 and 8 right here. And this is actually v at 20 minus v at 8. You know, we have that fundamental theorem of the calculus that when we take the antiderivative of the derivative, we wind up with this. Okay. All right. So that's what we have here now, and that's the same thing here. This is exactly the same as this up here, because this is in the denominator. This is 12, and we are looking at v at 20. This is over 1 if you think about it. So this is in the numerator, this is in the denominator. So every which way you want to do that is perfectly fine. I'm going to erase this one. I just wanted to show that method there to say, oh, okay, I do it this way. Well, either way is perfectly all right. Now we need to find out what v at 20 is. Let's do that. This is here's 20 right here, and it comes up to this slope right here. And we found from the last video that slope m is equal to negative 5. M is equal to negative 5 over 2. If you were to do this using the definition of slope, you got y2 minus y1, you've got 20. So m is equal to 20 minus 0 over 16. 16 minus 24. And what you're left with was 20 over negative 8, which reduces down to negative 5 over 2. So that is what you have to do there. So we found the slope, but that's not all we need, okay? I want the equation of this piece right here, of this piece of line here, okay? All right, so let's see. I've got my slope. So let's see, let's see, maybe I can put it right here, and I might just have to erase it. Y minus y1, which let's pick this will be fine. Or this will be just as easy. Here's x1, this is y1. Y minus 0 is equal to the slope, which we found here, negative 5/2 times x minus x1, which is 24. And then, of course, this is just simply y, okay, is equal to negative 5/2 x plus, negative times negative is positive, let's see, 5/2, negative 5/2 times 24. Okay, that's over 1. 2 goes into 2. 1 times 2 goes into 24. 12 times 5 times negative 5 times 12 is, well, that's going to be actually positive because a negative times a negative. That should be a negative there. Okay, so this would be positive 60 right here. Yes, that would be 60. And then when I plug in 20 right here, this is kind of like v at 20. So, okay, so y is equal to negative 5/2 times 20 over 1 plus 60. And we see this is immediately negative 50 plus, that's 60 right there. 60, not 6. Okay, now that is equal to negative 50. Negative 5 times 10 is negative 50, plus 60 is 10. Alright, we know that's 10, and it looks like it is anyway. I mean, but you don't want to go by what it looks like. Okay, So that's why I come up with that equation there to find out what V at 20 is. Okay, that's what I wanted to do. So I know that V at 20 is 10. Alright, so V at 20 is 10, and 10 minus V at 8. Alright, V at 8 is right here, and that's 20. We know that that height is 20. And we know that this was over 12 a while ago. This was 20 minus 8, which is 12. And so now this is going to be equal to negative 10 over 12, which is negative 5 over 6. Alright, so that is, and by the way, that would be in meters per, let's see, this is V prime, so meters per second squared. Alright. Alright. And of course, that's what we have here, negative 5 over 6 meters per second squared. Meters per second squared. Now, the question is, does the mean value theorem guarantee that a value of C for C being between on the open interval 8 to 20, that V prime at C is equal to this average rate of change? Why or why not? Let's take a little time. First of all, let's keep this on the side. We know that that is equal to negative 5 over 6, negative 5 over 6 meters per second squared. That's the average. Okay, we found the average rate of change. Alright, but the deal is that there is a sharp corner here, and that's why I just pointed that out. If you notice, 16 is between 8 and 20 on the open interval. Now let's review the rule for the mean value theorem. Mean value theorem. We've got to remember. Now it's different. It's continuous on the closed interval. Okay, and in this case we are looking at 8 to 20. Alright, that's probably why it's closed here. Alright, but also it's differentiable on the open interval from 8 to 20. Alright, and both of these have to exist. Now again, X and Y, and we come up with a curve like this, and we have a secant line. That's like the average rate of change here. We gotta have, there is a C somewhere between here, such that this slope of the tangent line, okay, is equal to the slope of the secant line. And that's what the mean value theorem says. But it has to be, the condition is, whether or not we know it's continuous or not, we do know that it's not differentiable. Okay. Okay, that's the point that we are making, we are asserting right here. So the mean value theorem cannot apply here, or does not apply here, does not apply to the open interval. Alright, 8 to 20, simply because we got V prime at 16 right here, okay, because it's not differentiable. differentiable at t equals 16. You might even say v prime at t. It's not differentiable there. Okay, v prime at 16. This slope is 0 to the left. This slope is negative 5/2 to the right. Now again, we could still find, as we saw, we can find the average rate of change on the closed interval, but we cannot guarantee. There's not a real guarantee here that we're going to be able to find that C in between 8 and 20, since 16 comes up right here. If that was not having two different slopes, then yeah, we got something going here. Okay, but we got to remember it has to be differentiable on the open interval. We can't include the endpoints because C has to be between those two numbers, not including the numbers themselves. Okay, continuous on the closed interval, but differentiable on the open interval, and now it's not differentiable here. So we don't know. We can't guarantee anything on that, simply because of this problem right here. Okay, this slope to the left of 16, t equals 16 is 0. This slope here is negative 5/2. Okay, it's not differentiable at t equals 16. So that's kind of where we are with that. That's why we have that situation. And this is one of the reasons I picked this problem out primarily to answer this D here, because I think you could probably easily do A, B, and C maybe. Okay, I'd have to go back over them to see what they would be like. But yeah, you could probably answer those. And so anyway, just keep in mind some things here. If we wanted to find, let's just erase this now. I think we've got that now. Just by way of reviewing very quickly what the whole thing was about, the A part asked about this. What does this mean right here? Well, that simply means you find the area of this. This is a trapezoid. Actually, you could probably divide it up into two triangles and one rectangle and find those three areas and sum them up. Or you can do a trapezoid one time and get that. So that's one thing. And this is distance here. Okay? When you integrate velocity, you get distance. And then I think they had something on V prime at t on the second one. Okay, V prime at t is actually A at t, and that's acceleration. So when you take the derivative of velocity, you get acceleration. Keep that in mind, but you're looking at this, and I think we had to compare V prime at 4, and they had us do two problems on this, and V prime at 20. And we found that we could do V prime at 20. That's negative 5/2. That's the slope. Okay, when you take V prime, you're taking the slope anywhere on that line right there, on any of these lines. Okay, and so this is the slope here. That means slope of the tangent line. So these slopes are negative 5/2. So this one would be negative 5/2, equal to that. This one, D and E, because this slope to the left is 5, and this slope to the right, where the corner point is 0. D and E here. Not differentiable here. Okay. Alright, and for the same reason that we did D, that's what we had there. Okay. I think C part had to do with finding this piecewise function in terms of the acceleration, which means you had to have those three slopes. So from 0 to 4, the slope is 5. From 4 to 16, the slope is 0. So the answer is, and I'll just do it real quickly. I know I'm running out of time. My camera only allows for so much time. But A at T is three things, because you got three separate lines, and this was part C, by the way. So it was equal to 5 when T is between let's see, T is between 0 and 4. Alright, it's 0 when T is between 4 and 16, and it is -5/2. So all you're looking at is slope. It's the slope of each tangent line. That's what A at T is equal to when T is between 16 and 24. And that was part C right there. Okay, that's just a very brief. I did that super brief right there. Okay. All right. And that is what you did on C part, and then we just did D just a while ago. Okay, that's it for that one. I will probably do another something out of a textbook. I'm going back and forth from a textbook concept, a new concept from the textbook, to a problem. Oh, I got a couple more 2005 problems to give you as well. So to keep tuning in, because you're going to get some of these. I know some of you are getting ready for that final exam. I think it's going to be, well, that final test is going to be in May, but you have a mock test, I'm going to say in March or April. I can't remember which, but probably in March. They want to get that so they can, any kind of thorns or thistles that are in there, they can iron all that out, get rid of those thorns and thistles in time for May. In April, get you ready for May. Alright, so anyway, and if you're just taking regular calculus, this is a good thing to look at too. Okay, and I'm going to come up with some more stuff. Please remember, if you haven't subscribed yet, please do so. That's always encouraging to see more subscribers. If you have a comment that you like to make, please make a comment. You can do that, and then hit that like button as well. So anyway, appreciate everyone. I really do. This is not for my glory, but it's for yours. This is KP the Math G signing off. Ladies and gentlemen, have a great, great day.